what we are doing for today, this is the whole point of logs, is how can we solve with them? How can you find the exponent using logarithms? So solving algebraically is the goal here. So the very first part, when it says, given the example, 5 to the x power equals 30, let's just predict the value of x, right? Using your knowledge of powers of 5. So all I mean by that, think about like, if I know what 5 to the first power is, that would just be 5. What about 5 to the second power? That would be 25. And then if I go one more, 5 cubed, I bet you know it, 125. What that means is if I want to know when does 5 to the x equal 30, well, 30 is just a tiny bit bigger than 25, definitely smaller than 125. So the exponent I'd have to raise it to has to be somewhere between 2 and 3 and probably a lot closer to 2. All right. So right now we can say x has to be between 2 and 3, definitely closer to 2. So this is where logarithms comes in. Now, technically, there's 3 different ways we can solve this. We're not going to solve every problem 3 different ways, but I want you to see the 3 ways, and then you can pick which way you prefer when you do the rest of the problems. So because we're going to solve this 3 ways, I want you to break up this space into 3 parts. And at the top of each part, you're going to write down the 5 to the x equals 30. Right in the middle one, 5 to the x power equals 30. Last one, 5 to the x power equals 30. All right. So here's the 3 ways you can do it. The first way is the idea of just taking plain old log of both sides to be able to use the log properties. All right. So for this first one, we're going to use basic or common log. So if I do log of 5 to the x and then log of 30, please make sure you write the log in front of the number, right? It doesn't make sense to write it afterwards. So just promise me that you're writing it down correctly, because technically you're taking the log like of what's inside here, the log of this, right? From here, the log property we're allowed to do is to take the exponent, drop it out front. So this becomes x times log of 5 and then equals log of 30. And as funky as that looks, remember, this is just a number. That's just a number. So when I want to get x all by itself, I would just simply divide by log of 5. All right. On your calculator, since it's common log, we get to use that log button, the one that's right next to the 7 there. Right? So you would just type in log of 30 and then close that up, divide it by log of 5. And that's how I get my answer. So 2.11, it's not going to be perfect, all right, because we knew it was somewhere between 2 and 3, probably closer to 2. So 2.11 looks pretty darn good there. All right, but we can say, it's approximately. And if you want to be able to check it, plug it in. 5 raised to the, 2.11 power. Does that make sense? Okay, it comes back to be 29.8. That makes sense that it's not perfectly 30, right? Because we rounded the answer, which is going to throw it off a little bit. So pretty close, right? What's the other ways you can do it? Well, we learned the other day to undo the base, you would do log using that base. So the second way we're going to do this is to do log base 5, right? So I would do log base 5 of 5 to the x, and I can do log base 5 of 30, right? Here, log base 5 of 5, see you later. That just cancels. Over here, what I get is log base 5 of 30, which you now know how to type into the calculator. If you have that log base button, here's your moment to shine. All right, so math, go up. Log base right there. And then you can type in the base of 5, type in the 30 here, and there you go. All right. So this is where you can use that log base button. If you don't have the log base button, you would actually calculate it using the change of base formula, doing log of 30 over log of 5, which is exactly what we did in the first one, all right? So this would still give me, that approximately 2.11. So same answer, all right? This is the one you'll probably default to just because it's the way I showed you the first time. But the last one I want to show you is that instead of using common log or using log base 5, you could actually use natural log or use the ln. It would be the same process as this first guy. So if I do that, I would do natural log of 5 to the x, natural log of 30, and then I would play the same game. I'm now allowed to take that exponent, drop it down, and I would have x times the natural log of 5 equals the natural log of 30. And then it's just x times some number. To get x alone, divide by the natural log, right? And just to prove it to you, natural log we know is that ln button right beneath where the log button is. So on my calculator, if I do ln of 30 and then close that up, divide it by ln of 5, there's that same 2.11, all right? So you can see no matter which way we did it, every single time we were getting that same answer there, all right? So there's that 2.11-ish. Let me zoom back out there. There we go. So the nice thing is I want you to recognize that you could do this so many different ways. You could technically do log base anything you want, but the ones that would make most sense would either be do log base 5 or maybe just the common log. But because you have this calculator button available to you, the natural log, why not? All right. So I'm going to go on the default that most of you are probably most comfortable with, that middle method. So when I do some of the following ones, I'm going to use that, right, in the notes itself. But you could technically do any one of these three. So when we slide down here, I'm going to slide my paper up. It says just solve for x to the nearest hundredth, so 2 decimal places. Verify using your calculator, meaning just check, all right? So if we use this here, what you have to make sure of when you're solving these questions is you can't take the log until the base is by itself. So write yourself that little note over here, all right? That is a little reminder, right? Get the base alone, then take the log. Right? So in this case, since it's 2 times 6 to the x equals 9, I am not allowed to multiply 2 and 6 together. It's not just a 6, it's 6 to the x. So instead, divide the 2 out. So that would then leave me with 6 to the x power, and then equals 4.5. So as a reminder, under math, there is the log base button. If you don't have that button, then that same exact answer could be attained by doing log of 4.5 and then divided by log of 6. All right? That's the change of base formula. All right. So for the next one here, same idea. I just still want you to go through and say, okay, how would I solve this? So when I'm looking at it, 2 is all by itself. So that means I can take log base 2 of both sides. So if I go log base 2 of 2 to the 3x and then do log base 2 of 16 over here, this will cancel. So I get 3x by itself. And then log base 2 of 16, right? That's actually a really pretty number. If you go to your calculator right now, you can do log base 2 of 16, and it comes out to be 4. Because if you think about it, this is the same as saying 2 raised to what power is 16? Well, 2 to the 4th power. And then when you divide by 3, you get 4/3. The reason that one comes out so pretty is you could have done this with common bases, which was in our last unit. So even if you just want to watch for a second, 2 to the 3x power equals 16. We could have rewritten 16 as 2 to the 4th. And here's where we would have said, hey, same base, let's ignore the base, set the exponents equal, and then there you go. All right. So you still can use common bases if the two sides of the equation have a common base. Where logs is really handy is it works no matter what the numbers are on either side. So it's got a nice advantage there. It's sort of like factoring versus quadratic formula. Factoring is great if you can factor a quadratic. If you can't, then use quadratic formula. All right, flip it on over. There's just a couple more that we're going to do together, and then the rest of it is practice, and the answers are actually on the back. I'll show you in just a minute. So for the ones like this, please make sure, get this guy alone first. That's your first goal. Don't bring logs into it until that expression is all by itself, right? So in this case, I would look at this and say, all right, I got to subtract 14 on over so that we get 8.29 times 2.7 to the x. All right, 45 minus 14. We're left with 31. All right, I got to get rid of the 8.29. You can probably already start to see this is not going to be the prettiest numbers, or these will not be the prettiest numbers in the world. That's okay. 2.7 to the x now is all by itself. You could leave this as 31 over 8.29, or just keep the numbers running on your calculator. So if I go 31 divided by 8.29, I'm going to get 3.739, and I'm just going to say dot, 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 because you are not rounding it in the middle of the problem. Say it out loud right now. I solemnly swear I will not round in the middle of the problem. Thank you. All right, from here, now we've got this by itself. Now we're going to take the log of both sides. So you could do common log, or you can stick with what we've been doing, log base 2.7. So if you can sneak it in here, do it. I'm going to rewrite it so I don't confuse anybody, but log base 2.7 of 2.7 to the x and log base 2.7 of 3.739 blah, blah, blah. All right. Left-hand side cancels. All I got to do is go to the calculator with this. So on my calculator, I'm going to do math, log base 2.7, and then I'm going to see if I can go up and grab that guy. Ooh, I can. Even better. And then that's going to give me 1.327, and it keeps going. So to the nearest hundredth, we'll solve all of these, which means x should be about 1.33. And then if you're looking and thinking, I have no idea if that's correct, type it back in and see if it checks. So the check part is as simple as take this 14 plus 8.29 times 2.7, raise it to the 1.33 power. Does it come out to be 45? Yep, looking pretty good right there. All right. If we look, the base here is e, all right? So e to the x is what I need to get all by itself. So let's think about what needs to move. I got to add the 3 over, divide the 4 out. Get that done first. So add 3 over. So we get 4e to the x equals 123. Get rid of the 4 by dividing both sides by that. You can leave it as 123 over 4, or change that into 30.75. As long as it's exact, or you keep it exact on the calculator, you're good to go. All right. Technically, what we would do is we would do log base e on both sides. But log base e, that is natural log. So here's where natural log comes in handy. So we're going to use natural log. So on the left-hand side, I'm going to take the natural log of e to the x. On the right-hand side, natural log of 30.75. Natural log and e cancel each other out. So knock that right out of there. And then x is equal to this. Go to the calculator. Type in natural log of 30.75. And that is your answer. So 3.43, right, would be the value of x here. We've got find the inverse of f of x. So that's what that notation is, f inverse right there. I know you know this. It means to switch your x and y. So since the original is f of x equals 5 to the x, remind yourself that's the same thing as just y equals 5 to the x power. Right? So I'm going to slide that. There we go. Flip-flop those x's and y's. So x comes here, y goes over there. And now to solve it for y, we have to undo the base. So the base is 5, which means we're going to do log base 5 on the left, log base 5 on the right. That cancels. And I'm left with y equals log base 5 of x. Or I can now call this f inverse equals log base 5 of x.